Hello. This experiment is to establish the relationship between pressure and volume for a fixed mass of gas. And what we are going to do is to prove that pressure times volume for a fixed mass of gas at any point is constant so far as the temperature remains constant. And the apparatus that we are going to use is the Boyle's law apparatus. Now this apparatus, we've got a gauge here which measures the pressure inside the system, and it's in PSI. Now if you look at this apparatus, if you check down here, there is liquid here, and then the top here is sealed, so between the liquid and the top here is air, a fixed volume of air which is trapped here. So what I'm going to do is that I'm going to compress the air by using this liquid here, and there is liquid here inside this reservoir. So when I pump the liquid up, the air will be compressed to that small volume, and as the air volume is reduced, the pressure will be increasing. So here what we are going to see is a trade-off between the fixed volume of mass here and the pressure. So as the air is compressed and the volume of the air decreases, then the pressure increases, and vice versa. So if we also allow the air to expand, then the pressure will decrease. So what I'm going to do is, I've got this fixed amount of inside here to where we've got the liquid. It's trapped, a fixed volume of gas, and I'm going to compress it. So if you can see, as the volume of air decreases, the pressure is increasing. The pressure is increasing. Now I've got the air compressed to this here, so the volume of air is now this, and the pressure has increased. So what we are going to do is, I will call one of my students to read the volume here. To read the volume, I probably can take it to a bit high. So here I've got this air compressed to this volume here, which is about 17.5, and then I've got the pressure increased to about 44 psi. So Jason, could you help me, give me the volume, the pressure, and then the volume, the corresponding volume, so that I'll be keying in here. So the volume, what is the pressure? Is it 44?
Yeah.
Okay, what is the volume?
17.5.
17.5. Sorry, you said 17.5, isn't it?
Yeah.
Okay. So what is the, take it to the next, maybe 40?
19.4.
So 40 psi is 19.4.
Yeah.
And then 35 psi. 21.9. Take it to 30 psi,
25.5,
25.5. And then to 25 psi,
30.5,
30.5. To 20 psi,
38.2,
38.2, yeah? 38.2.
yeah.
To 15 psi,
50.5,
did you say 50? 50?
yeah.
50.5. And then to 10 psi.
It doesn't go down to 10.
Okay, that's fine. Thank you very much. So, now if we look on the board, you can see that the product of pressure times volume is almost the same. The difference are not that big simply because maybe this is not digital one, it's analog reading that we've taken. So that might have accounted for these differences. But if you look at it, the first one, 44 and then 17.5 gives us 770. 40 and 19 gives us 776. 35 and 21.9 gives us 766.5, and so on to the last one, 15 and 50.5 gives us 757.5. So it tells us that pressure for if you have a fixed volume of mass, then the product of the pressure and the volume remains what? Constant. Now let's look at this one also. Pressure versus the reciprocal of volume, or pressure versus the inverse of volume. Let's draw a graph and see from here. And that graph should give us a linear graph. We should have a linear graph. And you can see that that is a linear graph. That is a linear graph here. That has given us a linear graph. Now let's also look at one last thing here. Pressure versus volume. The graph of pressure versus volume, and see how it looks like. So pressure versus volume. And that is exactly what I'm looking for. This is exactly what I'm looking for. Exactly what I'm looking for. So this is pressure times the inverse, pressure versus the inverse of volume, and that is pressure times volume. So what we've proved today here is that if you have a fixed volume of gas, then the product of the volume and of the pressure and the volume remains what? Constant. It's a trade-off between pressure and volume. When the pressure increases, the volume decreases. And when the volume increases, the pressure decreases. And this is what is used in pneumatics for the operation of those pneumatic components. You have to store large volume of air in a small container called the reservoir. Thank you for watching, and keep expecting more videos from me. Thanks. Bye.